So we talked a little bit about how to determine whether or not a relationship was linear using a table and a graph. And we also discussed the slope-intercept form. Now we're going to look at a word problem and we're going to examine the relationship between the x and the y here. And we're going to input all of our information into a table and then from the table into the graph. So the question here says, after collecting donations and pledges, Elijah wrote the equation y equals 3.5x plus 75 to represent the amount of money he will raise for running X laps in his high school's jogathon. How can you use the equation to create a table of values and a graph? So again, we're using this equation y equals 3.5x plus 75. Step one, we're going to substitute our values for x into the equation. So before we even get into substituting our values into the equation, I'm going to write the equation down and we're just going to discuss it a little bit. So y equals 3.5x plus 75. Now slope-intercept form, we already mentioned that y equals mx plus b, where the m is our rate of change. So in this particular problem, the 3.5, this is our rate of change. And if we make the connection between the story here, it's saying that this is the rate of change, which is going to show the amount of money he's going to raise for running X laps in his school's jogathon, right? So in this question, he's essentially earning $3.50 for each lap that he runs, right? They don't tell us that, but sometimes we have to break the question down a little bit further, right? So he's earning $3.50 for each lap X that he runs, right? Then it wants to know, how can you use the equation to create a table of values and a graph? So we're going to substitute the x values into the equation y equals 3x plus 5, and we're going to solve for y. Now, in step 2, we actually have some x values that we're going to input. We always say that x is our input and y is our output. So in this instant, if we look at the example, the x was 5. And again, our equation was y equals 3.5x plus 75, right? So when when x is 5, our y is going to equal 92.5, right? And if we look at the example, they took the 5, which was our x value, and they substituted it where the x would normally go, right? They plugged it in here where the x value would go, 3.5 times x, right? Which is 17.5 plus 75 equals 92.5. Now, they give us another x value. We're going to have to plug in that x value ourselves, and then we're going to have to find the ordered pair the way that they just did it, right? So I'm going to do it here on my board. So x equals 10, and the equation was y equals 3.5x plus 75. So we're going to substitute the 10 in for the x, which means we're just going to plug it in there. 3.5 times 10 plus 75. Now 3.5 times 10 would be 35. 35 plus 75 equals 110. So y equals 110. So let's make a connection because we need an ordered pair, right? They gave us an ordered pair here. We're going to put these ordered pairs here on our graph. So remember, our ordered pairs are always written as x comma y, right? Our x value was 10. Our y value was 110. So when x is 10, y is 110. I'm going to input that into my table. So again, we substituted the 10 in here. Then we had 110 plus 75, which equaled we had 35 plus 75, I'm sorry. 35 plus 75, which equaled 110. Our ordered pair was 10, 110, right? I'll do one more, and then I'll let you finish in the rest of the table, and then we'll go ahead and we'll put this information into our graph. So when x equals 15, right, which we see there, when x equals 15, we're just going to substitute it in for the x here in our formula or in our linear equation. So y equals 3.5x plus 75. We're going to substitute that. So we're going to take that 15 and we're going to put it in here where the x is, and we're going to add it by 75. So 3.5 times 15 is 52.5 plus 75. Y equals 127.5, right? So again, we're going to write an ordered pair, x, y. When x is 15, y is 127.5. So earlier we talked about x was our input and then y was our output. So notice we input 15 into the equation, right? And it gave us our output of 127.5. Now I'm going to go ahead and I'm just going to fill in this table here. So when x was 15, right, we ended up saying y was 127.5. This Sharpie is probably not the best thing to use in this situation. I like to use the Sharpie just because it shows up well here, but it's becoming a little difficult to write these small numbers. So just from these 3 points that we have here, we're going to plot these ordered pairs onto our coordinate plane. So our first ordered pair, 5, 92.5, right? It's always x comma y. So we're looking for the x. We're looking for this value along the x-axis, which is the 5. We always say that we crawl before we walk. So we're going to crawl to 5. We're going to walk upright to 92.5. So the line should be somewhere around here. Well, the point. The next point is going to be 10, 110. So we're going to crawl along our x-axis to 10. We're going to walk upright to 110. We should have another point there. Our third point was 15, 127.5. So we're going to crawl along our x-axis to 15. We're going to walk up to 127.5, which I'm assuming is right there. Again, this isn't perfect because we don't have any pretty points here, meaning we don't have a point where the line crosses the graph at two spots. And then one last thing that we didn't do was our y-intercept was 75, right? And we know this because this is written in slope-intercept form, where y equals mx plus b, and b here, this 75, this constant, is our y-intercept. It's the point where our line crosses the graph on the y-axis. So I have all my points, and I'm just going to draw a straight line through them. Okay, that's our line there. And this line would keep on going in a straight direction because this was a constant rate of change. It doesn't look perfectly straight just because of a little human error and also the way that the graph is drawn up. So what I want you to do is in your notes, I want you to answer, how can you use the equation to create a table of values and a graph? So that's going to be one of your questions in your Cornell notes, right? How can you use the equation to create a table of values and a graph? So we're going to look at one more problem, right? Again, these are in your notes. A landscape designer charges a fee for creating a design for a customer's yard. She also charges an hourly rate for doing the landscaping work. The graph shows the total amount the landscaper charges for X hours of work completed. Write an equation to represent the situation. Identify the rate of change and tell if the relationship is linear. So we're going to look at this table. We're going to look at this graph. They didn't give us a table, but we're going to take points from this graph and we're going to put it into a table ourselves, and we're going to determine if the relationship is linear, 1, and 2, we're going to find the rate of change here. Now, the very first thing when we're looking at a graph and they don't give us the equation or they don't give us the table is we're going to have to find some points on this line, right? And we want to look for pretty points. I stole that from Miss Melton. And pretty points are the perfect points where our line crosses at a perfect X and Y point. So if we look here, we have a pretty point here for our y-intercept. That point there, if we start here to read it, it goes nowhere on the x-axis. So that's going to be 0 for the x, and then it goes up to somewhere between 100 and 200, which looks like 150. So that first point, we're going to make a little table, our x and y values. That first point is 0, 150. Then we're going to look for some more pretty points. This second point here, we're crawling along the x-axis to 1, and then we're walking upright to 200. So the next one would be 1 and 200. Next pretty point here would be crawling to 2, walking up to 250. And then if we're doing another one, we're going to go to this point here, which if we crawl on our x-axis is 300. And then we'll do one more, right, which will be 4, right? If we crawl all the way to 4 and then walk upright to 350. Now, what we're going to do here is we're going to find the rate of change, right? Because we need to write our equation in slope-intercept form, y equals mx plus b, where m represents our rate of change and b represents our y-intercept. Our y-intercept, again, being the point, right, where our line crosses the y-axis, right? This is exactly where it crosses the y-axis. So first we have to find the rate of change. How much is it increasing by? What's the change in y over the change in x? So if we look in the change in y values, it's increasing by 50. It's constantly increasing by 50. Constantly increasing by 50. So our rate of change is our change in y over our change in x. We said our y is increasing by 50. And then if we look at the x is increasing by 1 every single time. So our rate of change here is 50 over 1. Right? So if what we're going to do is we're going to plug that rate of change in where the m is, because the m stands for our rate of change here, or our slope, is 50, right? So we have y equals 50x, and then we need our y-intercept. We said our y-intercept was the point where our line crosses the y-axis. If we look here, right, it starts at the x point, the x value of 0, the y value of 150. So y equals 50x plus 150. That's our equation for the line, right? So I'm going to write it again in another color so you can see it a little bit better. Y equals 50x plus 150. So what we did here, let's recap. We read the problem. We had to look at the graph, find points on the graph. We talked about finding pretty points, right? I stole that from Miss Melton. So we're gonna plot points where all the pretty points were, and then we're gonna take all of those points and take the x and y values and put them into a table. After we put them into a table, we're gonna find the rate of change, our change in y over our change in x. We found it was 50. Once you find the rate of change, you're just gonna substitute it or plug it in where the m belongs in the slope-intercept equation, right? That's going to be our m. Our x is always going to be blank or empty, right, when we create the equation. And then the only other thing that we needed here was our y-intercept, the point where our line crosses the y-axis. We knew that that was 0, 150, but we only need the y point here, which was 150. So our equation was y equals 50x plus 150, right? We identified the rate of change, and clearly we said before that in order for the relationship to be linear, there had to be a straight line graph, and 2, we had to have a constant rate of change, which we clearly have both here.